पुराने जमाने के
टीचिंग के तरीकों से
हमको क्यों पढ़ाते हैं? It's so boring.
अब वेदांतु देगा प्रॉब्लम से छुटकारा।
Hi kids.
समझ
Hello teacher.
आएगा तो मजा आएगा, मजा आएगा तो समझ आएगा।
Best teachers पढ़ाए तो simple लगे everything.
Leaderboards and quizzes से
Amazing.
learning हो जाए happening। समझ आएगा तो मजा आएगा, मजा आएगा तो
Vedantu. Learn live online. To attend a free live class, download the app now.
Hey guys, welcome back. Welcome to Vedantu's JEE channel. How are you all? कैसे हैं आप लोग? I'm sure that you guys are having fun already with us at JEE Sprint, another exciting session with this series of JEE Sprint 2020. Well guys, you know that JEE examination is happening next month and it's the sprint that you guys are running with us. I'm sure that there will be some nervousness which will be there, but yes guys, थोड़ा nervousness होना बहुत ज़रूरी है. Yes, because that brings the best out of you. So don't worry, keep yourself calm and you will come out with flying colors in the examination hall when you will be done with your examinations, and I'm sure that you guys will be making it to the best of the colleges which are there in our country. Okay, so guys, I'm back with another session that is semiconductors, as you can see it on my back. But before we go ahead, I want to tell you very important thing about this chapter. What is that? Well, usually semiconductor is one of those chapters which is being neglected by many students. We think that it is a very lengthy chapter in terms of theory, and it is actually. But then when I was going through all the questions which have come in previous year JEEs, I came to the conclusion that the questions are actually the most simplest of all. So far, whatever questions that we have taken in JEE Sprint here at Physics, you'll find that this particular chapter has the easiest of the lot. Yes, I'm not kidding, and you yourself will be able to solve those questions. As far as the theory part is concerned, instead of taking you through that lengthy theory, what I'm doing today, I'm basically attaching all the theory which is relevant for this chapter, the entire summary of entire chapter of semiconductors. You will find it in the description of this video. Okay guys, so basically all you have to do today is to follow me along with me and follow me to see that the questions which I'm going to solve, they are all laddu questions. Yes, that's how Pulkit sir takes a question for all of you, and yes, we'll be coming across many laddu questions today. So let's not waste any further time and go through the very first question, guys. Okay, so what you see here in the question is basically about a common emitter amplifier, which says that in the common emitter configuration, if alpha and beta have their usual meanings, then the incorrect relation between alpha and beta will be what, is basically what we have to find out. Well guys, you know that alpha and beta are basically the current amplification factors in a amplifier. So if we write the formula for alpha and beta, alpha is written as IC by IE, and beta, as you know, is IC by IB. Yeah, that's what is alpha and beta. And because we want to find out a correlation between alpha and beta, we need to somehow have a relation between IE, IB and IC, and I'm sure that you are aware about it, that IE is equal to IB plus IC. Now I have to use this information, convert it into alpha and beta and find out the relation between them. So what I'm going to do, because I can see that IC is the common factor between alpha and beta both, so I'm going to divide this entire equation by IC. Okay, so this becomes the rearranged equation, and now what you see, IE by IC is basically 1 upon alpha, and IB by IC is 1 upon beta plus 1. Do we have our answer yet? Yes, we see that option C is the correct answer here, but just not that. Till this year of 2016, you used to have questions which had multiple correct answers. So that's why we'll try to rearrange this, and when we rearrange this, we get it as 1 upon alpha is equal to 1 plus beta by taking the LCM, and now I can say that alpha is equal to beta upon 1 plus beta. So that is also a correct answer, that is option A. Okay guys, so what is not correct is B and C. So that is what the question is asking. So our correct answer, which we are supposed to mark, will be option B and D. Okay guys, cool. So that is our very first question. I'm sure that you guys found it, as I said, very easy. So guys, I'm sure that you guys are already having fun. For those of you who are watching me for the first time, this is me, your Suri Sir, and I'm also called as Mogambo because when you'll be solving questions along with me and very correctly when you'll be solving it, writing your answer in the comment box, yes, Mogambo khush hoga. Okay guys, so let's go ahead without wasting any further time. If you guys are having fun, just like, share and subscribe the channel. Okay, cool guys. Moving on to the next question, it says that if the ratio of the concentration of electrons to that of holes in a semiconductor is 7/5. Okay, so the ratio is given, concentrations, and the ratio of their currents is also 7/5. So current due to electrons to current due to holes has a ratio 7/4. Then what is the ratio of their drift velocities? Now this is something that we already know from our understanding from current electricity, that whenever charges are flowing, the current is basically given as, the expression for current is NEAVD, where I is current, N is the concentration of the charge carriers, which is basically electrons in the case of conductors. This is the charge of an electron, area of cross section of the conductor, and VD is the drift velocity. So if we write the current due to electrons divided by current due to holes, that is the ratio which has been given to us, will become concentration of electrons times charge of electrons, area of cross section, and the drift speed of the electrons divided by concentration of hole, same charge as that of hole, area of cross section, and the drift speed of hole. Okay guys, so EA get cancelled. What is given to us is IE by IH as 7/4, and NE by NH is given as 7/5. So VE by VH is what is to be found here. Okay guys, that means what we see here, this gets cancelled, and very simply what we get, VE by VH as 5/4, and yes, as simple as that is the answer to this question, which is option C, a question from JEE 2006. Hope you guys are finding this one as well a very easy question. Okay, yeah. Yes, it gets sometimes difficult to believe that these are the questions which have come in JEE examination, but yes, they are, and not just 1 and 2. Just see how many questions we are going to solve today which are easy. Okay guys, moving on. So this one is again a question from JEE 2006. What it says that the circuit has two oppositely connected ideal diodes. You can see those two diodes are there and they are connected in parallel. What is the current flowing in the circuit? Well guys, the thing that you should know about diodes is that whenever the current is flowing and diode is there in the way, like this, say this is your diode, this is the symbol for PN junction or diode, and if this is how the current is passing through the diode, we say that it is forward biased, which means what? It will offer very less resistance to the flow of current, which we most of the time in the case of ideal diode consider as 0. So there will be no resistance which will be offered by this diode in the case of forward biased, and it will just behave like a wire. But say if the case is just opposite, means what? If the current is flowing like this, then in that case the current actually will not be able to flow. If this is the theoretical direction of the flow of current, we first of all call this reverse biased condition or reverse biased mode of the diode, and in this case an ideal diode will offer infinite resistance and will try to block the branch in which it is present. And this logic will be required when you're solving many questions which have come in JEE, and in general when you're solving which are related to a diode in the circuit. Okay, now see this. So if this is the battery which is there, what we have to find out is basically the current flowing in the circuit. That means how much is the current which started from the battery. So I current starts from here, it reaches here, and now it should ideally branch out. But then if you branch it out, when the current reaches diode, that is D2, then you can find that diode D2 will be forward biased. That means what? It will let the current pass through it. And because nothing has been mentioned, we'll assume that it is an ideal diode. Both of them are ideal diodes, so that's why no resistance will be offered. Okay, so it will basically behave like a straight wire. But when we look at diode D1, you can see that it is going in the reverse biased mode. That means what? This branch will actually not let the current flow through it. Now means you can see that the current will not branch out. I current will pass through the diode D2, which is forward bias, passes through 2 ohms resistance, comes back to the battery. And that is basically the simplest circuit diagram that you see here with diodes which are connected. So now what? what you have is basically two resistances which are connected in series. Those are having 6 ohms of resistance in total. The battery is there. So R equivalent is nothing but 4 plus 2, that is 6 ohms. If we had been given the resistance offered by the diodes in the forward bias mode, then in that forward bias mode, we'll be using the value of that resistance also along with the resistance of these resistors. Okay guys, so what? Now we have to find out the value of I, which is basically V by R equivalent. So the voltage of the battery is 12, it's an ideal battery, and this is 6. Very simply we get the answer as 2 ampere, and yes, the answer to this question becomes option B. Okay, cool guys. Moving on to the next one now. Well, let's have a look at this one. I hope I didn't skip any question. Yes, I did not. So now what you see here guys is a logic gate circuit which has 2 inputs at A and B as usual, and we have to pick the correct wave out form. We have been given input at A, input at B. So what will be the outcome here? We know that logic gates are basically the semiconductor devices which basically take 2 inputs at a time maximum. The input can be either 0 or 1, which in electrical circuit equivalently is understood as for 0 switched off connection, for 1 switched on connection. So there are different types of gates that you, I'm sure, are aware about. If not, then the description has all the summary which is required for this. So these two guys are basically your NOT gates, which basically what do is they basically change the input and they invert it to the other value which is possible. Means what? For example, if say the input at A is 1, then the output after NOT gate will become 0, and if input is 0, it will become 1. So it just inverts the input which is given. And what you see here is first a NOR gate, and then you can say a NOT sign is there, means a circle you see, a small circle is there. So that basically makes this OR gate a NOR gate. Okay, so this basically becomes your NOR gate. Okay guys, what will happen for an OR gate is whenever the input of any of the input signals is 1, the output will be 1. If both of them are 0, then only the output is 0. So after putting a NOT gate, this condition will work and accordingly the output will change. So guys, let's first simplify the entire circuit here. So if A is the input and passes through NOT gate, then what you get is basically an inverted output, that is A bar. Similar happens for B, and this becomes B bar. Now, when A bar and B bar pass through an OR gate, the operator is plus. So A bar plus B bar is the output of an OR gate. But because there is a NOT gate is also there, so that's why you will put a whole bar over it. Okay, so that's basically your output. But then you know a property from Boolean algebra that A plus B whole bar is basically A bar B bar. That means OR gates output after inversion of the inputs become the output of an AND gate equal to that. Also, there is one more property that we should know, is that A double bar is equal to A, which means what? It says that if you pass an input 2 times to a NOT gate, then the output actually becomes the same which you started off with. Means what? For example, if I start with say input 1, it passes through a NOT gate, becomes 0. Again passes through a NOT gate, that 0 becomes 1. So you started with 1, ended with 1. Same will happen if you start with 0. Okay, so guys, now let's try to simplify this thing as per the rule that we know from Boolean algebra. So from there, following it, so I'll be writing it as A bar whole bar again, and plus will remove and will become a multiplication. So B bar is there, becomes another bar. And what is this now? A double bar is A, B double bar is B. That means it is simply AB, which basically is nothing but your AND gate. Okay, means what? What is given to you is basically a circuit diagram of an AND gate. And for an AND gate, we know that both the inputs have to be 1 to give you the output as 1. If one of them is 1, other one is 0, then the output will be 0. And obviously for 0 input of both, the output will be 0. So let me try to follow both of them. We know that the inputs which are starting are both 1. So you will have first output as 1 from that AND gate. Now this is 0 and this is 0, so the next will be 0. Now this is 0, this is 1, but in an AND gate it will remain 0. After that, excuse me, this is 1, this is 0, but still remains 0. Now both of them are 1, so again this time it becomes 1. Then both are 0, so this becomes 0. Now this is 1, this is 0, so it continues to be 0. So let's try to match it. You can see that when you compare these two, what you see, that correct answer to the question is option D. Yes guys, using the Boolean algebra, you can actually simplify very complicated circuit to a simplified version, and then you can work out with it. There is obviously a foolproof method where you can actually go with drawing the truth tables, but usually it gets lengthy, especially if the circuit is a very lengthy one. Okay, so I hope that you are understanding this part as well. Let's go ahead guys to the next question. Okay, now what you see in this question is that the electrical conductivity of a semiconductor increases when the electromagnetic radiation of a wavelength shorter than 2480 nanometer is incident on it. So the band gap in electron volt for the semiconductor will be how much? So band gap is basically what? Is basically the energy gap which we have to find out. Okay, so between the conduction band and the valence band for a semiconductor is to be found. So as per the question, the conductivity of the semiconductor increases. Okay, that means the gap decreases here. So we have to find out the new gap if the wavelength maximum available is 2480 nanometer. So to calculate the band gap, we'll be using the formula as hc by lambda. Yes, hc by lambda. Okay. Now guys, we know the values which are available here. So h is 6.63 into 10 to the power minus 34, just writing it as 6.6. C is the speed of light, that is 3 into 10 to the power 8. Lambda is 2480, not converting it into nanometer yet, but dividing this 1.6 into 10 to the power minus 9 for this entire expression of hc. Basically, I'm dividing hc by E. To convert the value of hc, which will effectively come in the SI unit system, I'm converting it into the electron volts form by dividing it by the charge of the electron. So when you will simplify this part, it will come out to be 1240 in nanometers. Okay, and this is 2480. In fact, you can remember this value. The value of hc for electron volt nanometer is 1240. So now you can see that it's a very simple calculation. This is 1 by 2. That means the value of energy gap is 0.5 electron volts. Easy it is. Yes guys. Question from 2005, the year when I appeared for JEE. Okay guys. Moving on to the next one. Now let's have a look at another question from Diode, and even further simplified question. This is basically diode as a rectifier, and question says that the PN junction diode shown in the figure can act as a rectifier, and this is basically a single wave rectifier. As you can see, there is only single diode connected. So as an alternating current source is now connected, so the polarity will keep on changing, the direction of current will change. That means there will be time when the diode will be forward biased and reverse biased as well. So we have to predict and find out that which one of the graphs is representing the current variation for the current with time. Yeah, the correct variation for the current with time when the current will flow in the circuit. So whenever the current will be moving in this way, that means whenever, say, this is the positive cycle of the AC. So for positive cycle of AC, let me just draw an AC cycle here for you guys. Okay, so this is our input cycle of the voltage, and if we talk about the current cycle, say this is the forward biased case, this is the reverse biased case. So in this case, we know that the diode will be forward biased when the current is flowing in this manner, so it will let the current pass through it. So this is what will be the output. After that, when the current changes the direction in the next half cycle, which is this, in fact the polarity of the power source changes. In that case, the diode will not let the current pass through it, and it will be just a zero current here. So this is I and this is T, which we are drawing, and again it will become forward biased, and this will keep on going as long as the current source is connected to the circuit, which means, guys, you can see that, you can predict it. Answer to the question is option B, with all the half cycles which are becoming crust and then no trough being formed. Okay, fine. So this was JEE 2009, and let's go to the next question, guys. Now this one is also a very simple one. I hope that you guys will be able to try this by yourself and will be able to solve it. Well, what does the question say? That the reading of the ammeter for a silicon diode in the given circuit will be how much? So we have to find out the reading of this ammeter. That means how much amount of current you think is flowing in the circuit. You can see that when the circuit diagram is shown as per the current direction, this diode becomes forward biased and it will not show any resistance, being an ideal diode. So what you actually have is just this resistance here, guys, and this battery connected. So all you have to do is now find the value of the current. So you have 3 volts battery connected over there, and resistance of the resistor is 200. That means you get 1.5 by 100 ampere. But as you can see, all the options are in milliampere, so I can say it is 1.5 into 10 to the power minus 2. So converting it into milliamperes, so this is 15 into 10 to the power minus 3, or simply 15 milliamperes. Yes, that's the answer to this question, which is option B, a question which came in the previous year. That is the reason that I've taken this question here. I know it's a very, very, very simple question, but just to tell you guys, just to show this to you guys, that still the questions which are coming in JEE from this chapter are very, very, very simple. You can see that it doesn't even take hardly or 30 seconds to solve this question. Okay, cool, guys. So these are the questions which are not just scoring or easy kill. These are the questions which actually save your time in the examination as well. Okay, chalo, moving on, let's have a look at this question. Now, what does this question say? Again, there is a diode. This is a Zener diode which is connected over here, and in the given circuit, the current through the Zener diode is to be found. Well, guys, do not get scared because of diode being in the circuit, as I am saying this again and again. So what is given to you, that there is a 15 volts battery connected, and there are 2 resistances, and to one of the resistance, that is 1500 ohms, a Zener diode is connected which has a potential drop happening for 10 volts. And we know that this diode and this resistance R2, they are connected in parallel. So can I say that 10 volts will be dropped here? And if these two are in parallel and getting the 10 volts out of the 15 one, so we can say that the amount of potential which is getting dropped on R1 is 5 volts. Means what? Say if I current started from the battery and I1 goes to the diode and I2 goes to R2, and they both, again by using the junction rule, join the value to become I again to reach to the battery again. So let's try to find out the value of I1 and I2, and then we'll be using the junction rule to find out the value of I1, that is the current which is flowing through the Zener diode. Okay, guys, so I will be equal to V by R1, and that is basically 5 by R1. Let's call it V1. So V1 by R1. So guys, V1 is 5, the resistance is 500. Not simplifying it, I want to write the value of I2 as well. Now I2 is basically flowing through R2. So V2 by R2. This is 10 volts and the value of resistance is 1500, which means what? Now I can convert this into 1500. I'm doing what? I'm basically multiplying this by 3 and dividing it by 3. So I have 15 by 1500 ampere, and this is 10 by 1500 ampere. So I have both the values, I and I2. Now you know that to find out the value of I1, we can say that it is I minus I2 by using the junction rule at this particular junction. Okay, so now what? I value, as you can see, is 15 by 1500, and this is 10 by 1500. So what do we get here? We have 5 by 1500. That means 1 upon 300 amperes. But again, because diodes are the devices where the current flow is very, very less, all the semiconductor devices have very small milli or micro level of current flowing through them. So this is ampere. To convert it into milliamperes, multiplying the numerator by 3 and denominator is 300. So this gets cancelled. You have 10 by 3, which is 3.3 milliamperes. Okay, so that is basically the current that is flowing through the Zener diode here, and the answer comes out to be option A, and no surprises. Still the trend is continuing. This is a question from JEE 2019. Hope that you guys are finding the questions very easy today, guys. Yes, one more question from the same examination of 2019. Let's have a look at this question, guys. What does the question say? It says that again you have been given the circuit which has two diodes, which says that they are ideal diodes, but when they are forward biased, they offer a resistance of 50 ohms, both of them. And obviously reverse bias they have not mentioned, because in reverse bias the diodes offer infinite resistance. They do not let the current pass through that branch. So if the battery is 6 volts and the current through the 100 ohm resistance is to be found, so we have to find out the value of the current through this resistance, which basically means what? Which is the current that is starting from the battery. Okay, so this current is to be found. Okay, so once the current reaches here at this junction, you can see that the current would want to go in this direction. But then what happens with D2? D2 gets reversed biased. That means what? It will not let the current pass through it, and this gets forward biased. So it will let the current pass through it. So if I try to redraw the circuit, forward biasing will have some resistance from the diode as well this time. So instead of drawing the diode, let me just draw the resistance from diode. Then there is one more resistance which is there, and the middle branch is equivalent of not being there because it is reverse bias mode of the diode, and one more resistance here. So guys, this is 50 ohms, this is 150 ohms, and this is 100 ohms, and the battery potential is 6 volts. We have to find out the value of the current which is starting from the battery and reaching 100 ohms as well. Okay, that means what? If we find out the value of our equivalent, you can see that it will be 50 plus 150 plus 100, because it is series connection for all of them. That means 300 ohms is the resistance. Let's find out the value of I now. Okay, so that value comes out to be V by R equivalent. And what is that value? V value is 6, dividing it by 300. What you get is 2 by 100, or simply 0.02 amperes of the current. Which means the correct answer to the question is option B. I think by now you guys have started believing that semiconductors as a chapter is not difficult, especially for exam like JEE. Okay guys, so here's your question for homework. I want all of you to try this. Take a screenshot of this thing. What you see is basically a logic circuit again. All you have to do is find out the output at Y. You have been given the input as A and B. All I can tell you that this one is a NAND gate, this is also a NAND gate, this is an OR gate, and this is a NAND gate. So there are 3 NAND gates and 1 OR gate being connected, and you have to find out the value of the output in terms of A and B. And yes, you can see again a question from JEE 2019. Well guys, I hope that you guys are able to solve the questions with me today. And so far, whatever sprint sessions which have been done, I would request you to go through all the questions which we have done, because those are majority the questions which have come in JEE previous examinations. They will actually help you to get the idea as well as the confidence that is required to appear for JEE Main next year in the month of January 2020. Okay guys, and if you are still looking for some chapters to be studied and you are looking for entire subject, entire PCM